Hey, everybody, again, thanks for taking some time to come watch another episode of DynamoDB Office Hours. My name is Rick Houlihan. I'm the Senior Practice Manager for NoSQL Services at AWS. And I'm obviously, we're here to talk a little bit about DynamoDB. Joining me today is one of my colleagues on the specialist team, Rob McCauley. Rob's been working with DynamoDB for years. He's here today to talk to us a little bit about cost drivers. Welcome, Rob.
Hey, Rick, really great to be here. I've been a fan of your show. I've been a moderator sometimes, and this is my first time being a guest, so I'm really delighted.
There you go. And you're the star. You're our guest star today. So one of the things that we talk a lot about with NoSQL technologies is really it's all about the access pattern, right? And what that really means is it comes down to how designing for cost, right? I mean, when we talk about access patterns and the velocity of the patterns and how to model the data efficiently, it's really about understanding what are those cost drivers, right? This is probably what we spend most of our time talking to customers about, right? When it comes down to modeling their data.
Mm-hmm. Yeah, for sure. It seems like designing to make it work is one thing, but you really have to design for cost to get the most out of your investment. And it's really the same as any relational database. I think you want to be aware as a database developer whether you have an index or whether the thing your code it's going to do a full table scan or not. So the thing I like about DynamoDB is you have to know that up front. Do you tell I want to do a scan or a query? So you really have good patterns to use the thing effectively, and then that helps with the cost.
Yeah, and the interesting things that come to kind of play is, right, the developer's bias towards, we always like things to look pretty, right? We always want to have nice efficient structures, and we kind of focus on the read side of the equation, right? And it's not often that we look at the entire picture and say, well, right, maybe I'm building this data structure that's very, very nice and pretty, but is it really cost effective, right? I mean, that's another thing I find.
Mm-hmm, mm-hmm. Yeah, for sure. Yep. Yeah, we like small items generally, don't we? Especially for intensive operations. But
sure.
There's so many decisions to make. I think we help customers all the time. First understand DynamoDB, but then make good decisions like capacity decisions and whether or not to create an index. Those are two that seem to come up a lot with my customers.
Absolutely. Now, and your background is really interesting. In particular, I always look at the skill set on the specialist team, and you were not just a solutions architect, right? I mean, you were also a customer, a user, an internal user of DynamoDB, right? I mean, how did you get involved in this crazy NoSQL world?
It's crazy. Yeah, I joined. I've been a database guy for most of my career, but I joined about 8 or 9 years ago, and I joined Amazon Robotics here in Boston, where I'm based, and they had just been acquired by Amazon to build these, warehouse robots, and they didn't have a data warehouse yet. So I was hired. I was the first guy. We built a warehouse using, commercial database engines. So I built a ton of stored procedures, a ton of ETL, Tableau dashboards, and got the thing up and running. And then after about 3 years, the Amazon Echo was released, and I was really curious. I would stay up late trying to hack it, ask it questions, got into SDK, and was like, whoa, I can code this thing too. So I was able to transfer into that and become an SA for Alexa. And it was there that, we started to realize that, when you come back to a skill a second time, it doesn't know anything about your other session unless you write that in. So we would code in DynamoDB calls, puts and gets. And I was like, wow, this is a lot easier than the databases I've used in the past. It's really developer friendly. And I totally get, I can store, big JSON document of all of my state. And then, state comes back and just like we never skipped a beat. So I was a customer, and I was really intrigued by that too as well. So about 3 years after that, I came over. Yeah. Mm-hmm.
Yeah, no, that's awesome. And what you kind of described there was a lot of developers' first introduction to NoSQL. It's like that key value access pattern, right? Get me this state object, get me this, collection, and as you start to explore, DynamoDB, NoSQL databases more in depth, right? This is where you start to realize that, and I don't know where your, what epiphany occurred, right? But usually what happens is, we'll kind of explore this key value access pattern to the point where we start working with the data very inefficiently, right? We start, reading and writing big blobs of data, to access small bits of data. And, this is where, at least when my first introductions to NoSQL, I thought I was doing things great until I found out, that my storage arrays were on fire, right? This is before I even joined, AWS, and I was working with the legacy, technology providers and fixed infrastructure environments, right? So anyways, let's talk a little bit about those cost drivers. What are the things that we need to, it looks like we're in the wrong part of your presentation there.
Oh yeah, I'm going to do a quick review of the capacity modes, and then we'll jump right into the cost drivers.
All right. Okay, great. Let's talk. So one of the things about DynamoDB that's kind of one of the more interesting aspects of DynamoDB is the ability to change how you're billed, right, for what you use. And a lot of this really is reflected by your, again, access patterns, right? What are they like? Are they constant and scaling in graceful manners throughout the day as your users wake up and use your services and then eventually retire for the evening and things go idle? Or is there like real vertical spikes that we have to support? So let's talk a little bit about what kind of capacity modes exist to support those workload types.
Yeah, for sure. Yeah, that's the first decision you'll see as you create your table. There's no servers, of course. You just create a virtual table, and then you're like, well, what capacity mode do you want to be in? So here's what you'll look at: on-demand or provision. Now, we recommend customers start with on-demand. It's much simpler. You just pay per request, and there's really not a lot of decisions to make about capacity levels or scaling or anything.
But so on demand, would you say that on demand? I mean, I always tell people to start with on demand, right? And because on demand gives you kind of the ability to support whatever you need, right? You can provision the table at some point to some expected maximum throughput, then switch to on demand, and you don't have to worry about it. But it is more expensive, right? It's a lot more. It's not necessarily something I might want to run on. But so, what kind of workload fits in an on demand billing capacity?
Yeah, I think that for on-demand, it seems like spiky workloads are the best, and also new workloads. Yeah. We've seen customers create a table with a provision capacity really high, and then 3 months go by before they launch their project, and so they might be provisioned too high without a lot of traffic. So with on-demand, it takes away the risk of over provisioning. It also, I think, takes away most of the risk of under provisioning, because it's really like our premium pricing model, and it can scale up very fast. You have 4 times the capacity, I think, for a brand new table. And it can go up fast as it sees your traffic patterns. So great way to start. Great way if you have really spiky patterns. If you had like a spike once every hour or so, that might be a good pattern as well.
Sure. So what are the other options that we have besides on-demand? Because on-demand is pretty expensive compared to provision throughput. So what are the other things we can do here?
So yeah, once you've been live and you see what your access patterns are, if they are kind of gradual or steady, like you said, coming in the morning and going at the evening, then you can switch to what we call the provision capacity, the default original mode. And here you have like a control, like a throttle, or well, that's not a good word, but you have a lever where
you have control, right?
You have control, You set it to what you want. So if you're also the developer and you're driving the traffic at a certain rate, you just set your capacity level to that rate, and you'll really be efficient, and you'll save money. So you can bring it up and down at any time.
So this is a good mode for, like, for example, if I was a developer and I'm running an ETL process, or I'm running a scheduled batch workload, right? And I know that, while this workload is running, I'm going to need X, but when I'm done, I don't need it anymore. So I can manually go in, I can turn the table up, and I can turn it back down when I don't need it. This is actually one of the biggest benefits of a shared backplane service like DynamoDB, right? It's the elasticity. Right. And what we're kind of showing you is, we have this on-demand billing mode. Yes, that's rather expensive. But if you have a spiky workload and you don't really know what the pattern looks like as far as demand pattern, then that can be your best bet. As a matter of fact, I remember when we introduced on-demand capacity, I thought it was going to flop because, literally the price is 7x the rack rate with no discounts. Right. And I thought there's no way anyone's going to use this. But as you pointed out, when users launch new services, they don't understand, how much they need. Or, heck, I had customers that are saving 90% over their previous bill because they were provisioned for their peak throughput, and they had to be there all the time, even though maybe only an hour a day they actually ran their work. But it was just spurious spikes during the day. They had to respond. They couldn't wait for auto scaling, right? They didn't know when it was coming, and they couldn't delay the work, right? So it was a really good feature. But the ability of the developer to go in there and adjust those levels, depending on the workload that they know they're running, is another real key feature of the system, right? You don't have to, provision for peak workloads and then let it sit there when you're not using it. And that's the biggest problem with the legacy tag.
I think so. Yeah, exactly. Yeah. So you can imagine API calls to just set the capacity up and down right before and after your batch job. And we'll see some of that in the demo in a little bit. Yeah. Okay. So we have on top of that now we have an option. Rick, do you know about this? Auto scaling.
Yeah, just a little, right?
yeah, exactly. So it sort of automates some of that scaling. So if you had a steady pattern like this, right, it'll scale up. It basically creates trigger alarms in CloudWatch for you that are going to perform these actions based on some metrics. It looks back at 2 minutes of increasing traffic, and if it sees the traffic surging close to its thresholds there, it'll boost your capacity automatically. So less maintenance, less decisions to make, and then it'll come back down more conservatively every 15 minutes or after a while, once an hour. Yeah.
So now this is interesting because there's a lot of other there are other NoSQL managed services out there that talk about auto scaling, right? But what we're demonstrating here is a level beyond anything any other provider that I'm aware of can offer. These are step ups in minutes. These are step downs, in minutes through the day. We're not talking about needing to see hours of increased utilization and days of decreases before we step up and down, right? It's like very dynamic. Now, and most workloads, right, they have this type of curve. I mean, in my experience over the years, I've kind of seen this application demand curve through the day. In the beginning, it's not so busy. Through the day, it gets busier. People wake up, they start driving traffic through the service, or there's almost every service has a curve that it follows on a regular basis. Now, whether it fits the auto scaling mechanic or not is maybe the question. But I would posit that the vast majority of workloads actually do, right? And based on how I see our configurations and our deployed tables, I think it supports that statement.
Yeah, I think so. Yeah, exactly. So the only twist with auto scaling is that it takes a few minutes to scale up. You can see on this right chart, it's rising rather fast. It does stay ahead of it, but if it were to spike up, twice as fast as this, it might have a couple of moments of risk where, you might be retried. You might, get away with it with our burst capacity feature, or you might actually get, throttle errors or exceptions.
Right. So this is where, let's talk about that for a second, right? This is kind of where it's like the slope of that demand curve. That's going to dictate how well you fit into your auto scaling model, right? We got a couple of ratchets, and Rob's going to walk through these. He's built some really good tools for kind of analyzing your auto scaling, the what you talked about, the risk, the throttling risk, and as you scale, and we'll show you those in a second. But this is where you're going to make that decision. At some point, there's a break point. You're going to look at it and say, I'm going to have to go on demand. Right. Or I'm going to have some sort of trigger event that's going to cause me to programmatically increase the traffic on this table to avoid or throughput on this table to avoid, that risk of throttling, or right, you can accept it. Right. I mean, you can always do back off, retry, and accept the fact that you're going to experience some throttling while the table scales. So again, depends on the nature of your access pattern, the priority of the workload, right? How critical is it that this is, and the latency requirements as to where you go here. But what we're kind of showing you is that we've got multiple modes to operate in that fit multiple types of workloads, and there's always going to be a good fit for you.
I think so. Yeah. You're right. So in a moment, we'll show you the Excel models that we've built to demonstrate, when on-demand or provision capacity might be appropriate, and also look at the GSIs. But a little bit of recap as well. We did a talk, didn't we, Rick, just recently about from Database Modernization Week, where we covered some of the top 5, cost drivers that we see customers, we see designs that may not be the most cost effective. So the first, we'll cover a few of these. The first is using large objects with DynamoDB. It's maybe useful to tie DynamoDB to your S3 bucket to store pictures, images, really large documents that don't change often in a bucket, and then have DynamoDB as well to provide an index and a way to search and identify items. That way, the index here on the bottom half of this screen will be just your table with your attributes, and we can model this really nicely, I think, with the partition key and the sort key in blue and green. So you might just have your bucket name being your partition key, and we could easily do a query for everything in the bucket. We can also do, of course, sort key expressions to go left to right on these green values here, the second half of your primary key, and say, get me everything that begins with vet visit /2020 everything else will be after that could be a wildcard, and we can identify those records. And then if we really want to pull them, we can pull them out of S3 and then take advantage of the much lower storage cost for S3.
Sure. I mean, regardless, I mean, this is indexing. This is like creating an index on the bucket, more or less, right? Where you say you're partitioned on the bucket. But regardless of the access pattern, it could be, hey, I want to organize my vet visits by my customers, right? That could be a customer ID. The only thing I really need is a pointer to the S3 object, right? And if you think about it, most of the access patterns, this is a really good workflow because, most of these access patterns are going to be kind of list driven down to the point where you select the object, right? I don't necessarily want to store all the object details on the table in every one of these items, because now as I'm reading through these items, I'm reading all the details. I really only want to store the pointers. And then when the user clicks on the object, hey, that's when I need it. So this is kind of this is a really good pattern. I talk a lot about this. It's like vertical partitioning, right? It's like, let's not create, and this works not just with an S3 bucket, but it could very well be that some of that large data needs to be online. I need the low latency, maybe it has high update frequency and it's not really a large enough item to be efficient in S3, right? Because as DynamoDB, surprisingly enough, is quite efficient when you have high velocity updates against objects that are 10 kilobytes, 20 kilobytes. S3 doesn't do so well, right? If the updates are high velocity, the actually cost profile gets you because you pay per request, right? So again, depending on the nature of the access pattern, I could actually use this exact same approach, but partition the data and say, the big data sits in an item over here that never gets read. The small data is what gets read and indexed and creates the lists. But regardless, what you're kind of pointing out here is that it's a good pattern to kind of read and write the data that you need and store the larger objects off on a cheaper infrastructure, and it's exactly the pattern that we talk to customers about quite frequently. I think it's good to recognize this as a top 5 cost driver because that's what it is: reading and writing data you don't need, storing large objects on the table when they don't really belong there. That's a big gotcha that users run into all the time.
I think so. Yeah, right. Exactly. Small items. Looking at this, we could even optimize this more. Maybe it's just the status that changes every day,
right?
Or the temperature or something. Some things that don't change often, those can be deferred to the document or a different part of the item collection, perhaps.
That's right. Yeah. Exactly. If I have like a small chunk of index data that gets updated frequently and a large chunk of raw data that doesn't get updated very often, then I don't want those living in the same item. Right. That's going to cost me every single time I update a small bit of data. I have to read and write the large data payload. Right. So whether I store that larger chunk in S3 or I store it as a separate item on the table, regardless, I don't want to have my update workflow have to touch that data. And honestly, that is one of the biggest gotchas. When I was at MongoDB, we had that problem. Customers would create these giant documents because they support a 16 megabyte document size, right? And I would always go into these environments. I say, well, how often do you read those? Do you need all that data when you go and get the documents? Like, oh, no, I usually just have to update this counter, or I only want to see this little bit of metadata. It's like, well, did you know that you're paying the IOPS to read and write the entire thing, right? And this is, again, I said, my storage arrays were on fire before I figured this one out. And so, this is just one of those gotchas that when you get into modeling in NoSQL, it's like after the fact, you're like, oh, of course, right? But while you're doing it, you're like, hey, it's great to have this giant document until it's not.
That's right. Yeah. Yep. Exactly. Here's another good one too, is the TTL feature. Yep. So, we don't have date time native format with DynamoDB tables, so you're free to choose a number or a string or your favorite date encoding. But standard option, the least storage is just a Unix epoch date as a number type in DynamoDB.
Yep.
Right now, if you do that, you also have the option to create a TTL attribute on this, and what that will do is tell the table to treat this as an expiry time, and the system will go through every few hours and look at all the tables that have TTL and just find any that have passed the expiration time and go ahead and remove those for you at no extra charge. Whereas normally, if you did a delete, that would be a write operation, the same charge as an update or a put item. So being able to expire old items, maybe you only need to keep it for 12 months for legal reasons, and you just want to get rid of it after that, or maybe you want to expire it and move it to your vault or your data warehouse at some point. Yeah. So we can do all that with the TTL expiry feature.
Just a short anecdote on TTL. Back before this feature was released, I was working with an internal service team that was had this requirement. They needed to age out the old data. They were one of the drivers for the feature, right? We have these things called PFRs internally, as you know, Rob. And this one was bumped up the priority list simply because we had so many teams that needed it. I had a team that was, they knew this feature was coming before they launched their service. This was back when we were doing the Rolling Stone initiative and deprecating all of the Oracle servers and moving all that stuff over to NoSQL, right? So these guys knew that TTL was coming. So they added the feature, they added the attribute. So it was there when the feature arrived. Well, the table was 43 terabytes when the feature arrived, right? And after they turned on TTL on the table, it dropped to under 4 terabytes, right? So almost 90% of the data was cleaned off of that table, right? So, and this is the problem with this type of stuff. Before TTL, it was a manual process. How do you get rid of it, man? I got to scan the whole table. I got to create an index. I got to, it was a terrible process to clean this data off of the tables, right? So, this TTL feature has been just solid gold to get rid of all this stale data. I always recommend that people tag these things with, that Linux Epic timestamp that whether or not they think they're going to need it, put an expiration on that data. You can always enable it, right? Yeah.
Yeah, I love that. Yeah, put a number in there. Use it. It's if you wanted to update that number, that's the same cost as just deleting it. But if you are going to update other attributes in there, that's a good time to bump the expiration time.
Yeah, absolutely, and that's what we'll do all the time. Yeah. That's what I recommend with customers do every time you touch the item. If you have like a 30-day retention policy, then just always update your TTL attribute with every single touch, and you're guaranteed that Now TTL is not immediate, right? This is something that is we will use extra background capacity. There's a sweeper that runs across all tables, multiple sweepers, but regardless, it will eventually remove the item. And I think what's the guarantee is like within 24 hours or something like that. What is the guarantee?
Within 48 hours, but typically just a few hours. Yeah.
Yeah. Typically it doesn't take that long, but again, if the infrastructure is busy for high velocity, with high velocity workloads long enough, that's why we don't say there's no guarantee on that, but it will delete within a couple of a 48-hour period.
Yeah, exactly. All right, so what's wrong with this chart? This is like you're right from CloudWatch. This is a table with read and write capacity on the GSI. That's the global secondary index that you can create on your tables, and they're like little mini tables, so they have their own read and write provision capacity and then consume capacity in orange there. So what do you think,
this is what we just talked about, right? This is, developers have a tendency to want to create beautiful read structures, right? We want to have our data laid out nice and organized. So what this service team did was they built a GSI to satisfy an access pattern that's extremely infrequent, right? I mean, is what I'm interpreting here. There's almost no read activity on this GSI, and we're constantly churning it because we have to maintain the data structure, and that's causing essentially a wasted capacity throughput. Now, at some point here, and this is, I believe, one of the tools that Rob's built, will kind of tell us, hey, when does it make sense to create the GSI based on the amount of read activity we see? But this imbalance is indicative of an over-designed data model, right? It's like I optimized a data structure that didn't really need to be optimized, or likely, because what I'd probably do instead of creating this GSI is just execute a table scan and grab the items that are interesting, right? Based on the structure that this GSI is maintaining, right?
Yeah, that's it. Yeah, exactly. Yeah. If you have any GSIs that are getting no reads, then why do you have them in the first place?
Yeah. Or I mean, if it gets one read a day or something like this.
Even one read a day. Yeah, exactly.
It's probably easier to, like I said, and again, that depends on the size of the table, right? I mean, if this table is 43 terabytes and I need to find a couple exception items, right, then it might be better to run the GSI. But that's something that Rob's tools are going to help us determine. When does it make sense to create a GSI versus execute a table scan? Yeah,
exactly. Yep. All right, well, I want to get to those labs. I'll plow through the next couple. So provisioning too much, don't. This is like we talked about in the beginning. Use OnDemand. If you don't over provision, unless you really need it, you need it. But just start with OnDemand, and then you have less decisions to make.
And that's the key. That's a big key right there. Start with OnDemand. People note that one down, right? If I have a service and I don't know what kind of traffic I'm going to get, you know what? Over provision the table, switch it to OnDemand, and then watch it for a week or two, and then you can use the CloudWatch metrics to tell you what you need to do, right? And running that table for a week or two in OnDemand mode is not going to break the bank. right?
Yeah.
But it's going to give you some solid data that you can use, and it's going to guarantee that your customers have a good experience and you don't under provision and screw up the throttle and start throttling and all that crazy stuff. So I always tell customers, unless you have a really good idea what your traffic profile is going to look like, launch that table in on-demand mode and use those CloudWatch metrics to tell you what to do in the end.
Mm-hmm. Yep. That's right. One final thing, I think we touched on this, denormalizing too much. So here we have an item collection. You might query for a product name, and if this is being updated often, you see the quantity there, it's getting changed by a developer. But there's also this item is 10 or 11 kilobytes in size. So it may be a surprise to know that updates, you can certainly update only one attribute and just give us that, but we're going to, DynamoDB will charge you for the full size of the original item.
And not just DynamoDB, but all NoSQL databases, right? This is this is why we just talked about this. Boy, these 16 megabyte documents are great, and until they're not, right? I mean, you don't want to pay 16 megabytes worth of IOPS to update an integer value inside of a JSON document, right? And that's honestly, it's funny how often that happens when you walk in and so really the crux of NoSQL data modeling is about creating smaller objects and using indexes and partitions to group them together. And so this is why oftentimes we talk to customers and we kind of let them know it doesn't really matter if you're in a document database or a wide column database or what NoSQL database. It's really about the indexes, right? That's the most important aspect. How am I grouping the small objects? Because the data, think about it as a developer, right? Your application works with data in small chunks. It does not work with big, giant, relational structures. It works within those structures. It pulls rows off of tables. It pulls and it updates, individual columns within those rows. It never updates every row on every table when it makes so why would I want to store data in a structure that's every row across the relationship, right? Sorry, I'm kind of getting off topic here, but
good.
Modeling is such a big part of cost efficiency, right? They just can't get around it.
You get around it, yeah. I think the problem here is, we denormalize sometimes with DynamoDB. The description here is the big payload. That's 10 kilobytes. And it's duplicated. This would be fine if it's, read heavy application and you just want to do a get item and, get the description. But in this case, if it's really write intensive, we can think about the item collection here and just put that description maybe at the very bottom in a special tagged item with a special sort key. Okay, and then we can easily do a batch get item to get the one we want. It's small now, easily updated, and then the actual description as well.
Let's say the access pattern was, get me all the turnips ordered in the last, whatever, right? These look like orders or whatever, right? So I could say, okay, that brings back all the orders plus the status, right? If it's greater than, 5 days ago or whatever, right?
Yep. All right, so let's jump to the let's take a look at some of the models. So what we have here is, let me bring up the website. So if you go to this site, this is my GitHub, Rob M26. You can see I have a cost modeling workshop, and we did this recently. So the idea here is we can start to plan for the cost of our table even before we build it, right? We can do this all in Excel, for example. And the two things that I like to help customers with is search strategies. I want to search my table. Oh, great. How often do you want to search that? And we want to understand that. Is it once a month or is it once every minute, right? And so we have this worksheet here, filter versus global secondary index. And this is, you can try this out. Bring up that chart. So should I create that GSI? So this is a real life model. And the way I built it is just with a data table here on the bottom, where I sort of iterate through 30 days of a month. And we do the cost comparison in blue and orange between doing a full table scan. That's the blue one. And then the orange one would be the cost to build a GSI. Now, oftentimes we think we should always have GSIs. They're more efficient. That's true for the write side, for the retrieval side, but it also has an overhead. If you're going to require writes to the base table to be in the GSI as well, then that's going to amplify the whole total write bill that you get. Right, and that's what we see in the orange line here. So this is the way this model works. You can try it out yourself. You can change any of these green items. The table size is 50 million items right now, average item size of 4 kilobytes. And this is true, if you have any size table, really, the model is the same. But the key thing here is the table writes are 20,000 per hour, right? If we did 2,000, you can see the cost of the GSI is much less now.
So this is really cool because we just talked about this, right? It's like, when do I make the GSI versus the table scan? And this is a nice tool to show you exactly that. Hey, if I got, you can nail it, right? Here's my item count. Here's the size items. That tells you exactly what the cost of table scanning that table is. We know what the cost of maintaining the GSI is based on the amount of WCU, RCU capacity, and the size of the table, how much projection is going to happen. It's very easy to determine where that breakpoint is, right? How much below that orange line, if you've got a GSI configured, you're burning dollars, right? It's above the line is where it starts to become more efficient for you, right? Is it vice versa? I can't remember.
Yeah, that's right. Exactly. Yeah. So the trade-off is, if you did about 17 full table scans a month, it would be the same price as, the maintaining that GSI for all time.
Yeah, exactly. Yes.
And just using the GSI. Yeah. So that's your break even. If you're doing it once a day, then, I think the GSI makes sense. But if you're just doing it once a week now, then, you maybe don't do a GSI and just do a scan. Right. And you can even see the cost. That would be, $50 a month for a really large table. That might be just fine. That's, less expensive. So the key thing I want to show here now, here's an example of the table that we might be modeling. And it's got an unindexed attribute called product, right? There's different products. There's some cars, some trucks, some bikes. Let's say we're the product owner for car, and we want to understand how many, get me all the items that have car in them. We don't have a GSI yet, so we can do the full table scan. But it really depends a lot as well on how many items are in that table. Is it 1? Is it 10? Is it 10 million? Right? Because those are also going to affect this model. So let's play with that a little bit. So we're returning 10 items per search. That's really negligible. That's the GSI query cost. It really rounds down to 0. You see in this column here.
Sure.
But if let's say there was 10% of the items were cars. So I'm going to do 5 million. Now which is more cost effective?
Yes.
So the GSI, now we start to see the cost of retrieving 5 million items starts to add a lot to the price of the GSI.
Exactly.
Whereas the full table scan, it's one scan. Don't pay anything more than that. We do all the filtering on our side for you, which is even that's a hidden benefit, I suppose.
Nice.
Yep.
So real quick, I'm going to divert here because I saw a question come up in the chat that we get a lot, and it has nothing to do with our topic, but it's rather important, right? So the question here is about consistency, right? So what do you recommend for product stock? There's a side conversation going on. I just want to call this out. Yeah. DynamoDB does not have the latest item updates, so I need to use all the time strong consistency. So DynamoDB is actually a consistent database. You can, if you need the actual consistent product stock number, you can make a strongly consistent read. That's going to read the item from the node which accepts the writes. All writes go to the same node, so you're guaranteed that there's consistency when I'm making an update. And you can actually make updates with conditional checks, right? So if I read the item and I got some stock, maybe I even made an eventually consistent read, right? Because EC reads go to the secondaries. So we might get data that might be slightly inconsistent. I can always use a conditional check when I make the update and say, okay, let me adjust the stock if the stock is greater than X, right? So if I read something from an EC read, it comes back slightly inconsistent, I try to order too much, or I try to use a number that doesn't exist, I can always validate that when I make the update, right? There's no active on a single DynamoDB table in a single region, right? Now, across regions, global tables, all bets are off, but that's a different problem. But just so people understand, DynamoDB is not an eventually consistent database. It is a strongly consistent database. And so those kinds of problems are relatively straightforward.
That's a great point. Yeah, that even ties into the cost a little bit, right? So developers have the option.
Oh, it does, as a matter of fact. Yes, as a matter of fact.
Yeah, you can do strongly consistent reads where that's critical to get the latest value. But for most, a lot of the applications we see internally, we can relax that a little bit and pay the 50% discount and do a default eventually consistent read.
Yeah, eventually consistent reads are half the cost. It's a cheap way to double the throughput on the table, to double the read throughput, right? And understand also that when we talk about eventually consistent, what is eventual consistency? Well, in a properly configured table where GSI replication is keeping up and we don't have hotkeys, we're talking about 10 milliseconds P99 latency on GSI replication. So, read after write acknowledgement from the client is never going to catch that, right? You're going to be more than 10 millisecond latency round trip. So the reality is it's for all practical purposes, it is consistent.
That's right. It's a great point. Cool. Yeah. All right. A little bit more about this model here. We We can optimize this further. If you think about this base table now, and there's a potential GSI that's going to be created. When you create a GSI, it'll copy and duplicate everything in the base table into the GSI, including maybe this contract. There's another large payload, perhaps, that doesn't really change often. It may not be critical for the GSI query. So we can not project that into the GSI. When we create the GSI, we have the option to just specify the attributes we want to live in there, and everything else will stay out, and that will make the GSI a lot smaller, and that can reduce the cost. So what I've done in the model to show that is I've been this replication percentage. So instead of 100%, maybe we take out that JSON document and we're down to 50% replication. Watch what that does to our model. See, the overall cost of replicating writes to that now is cut in half. So the GSI is much more efficient. That's one technique. And we can also maybe make the GSI a little sparse. Maybe the product owner for car is the only person that's asking for this type of request. The truck product owner doesn't care, the bike owner doesn't care. What if we were to make a GSI or just structure our data such that there's another attribute called cars, yes or no, and it says car in there or no, and those are the only things, right? So it's null for most of the time. That would make the GSI less, smaller in size as well by creating a sparse GSI.
Yeah. I just had a customer the other day that was it was a census customer. They had this is a great example of what you just kind of described. They have a bunch of unclaimed IDs that were sitting in a partition. When users would come in, they would claim an ID, and they were marking the status of the ID claimed true or false. Right. Well, they didn't care about claimed IDs. They only cared about unclaimed IDs. So, essentially what they were doing is double tapping the GSI every single time somebody claimed an ID, because they were, instead of deleting the attribute, they were switching the value of the attribute from true to false. Well, two problems here. They only had two partitions on the GSI, right? They had the true partition and the false partition. Each one contained, thousands, potentially even millions of these GUIDs. And they would come into the true partition and grab the first one and then switch it to false. So that caused a write on both partitions, which caused a double hotkey. They couldn't understand why they're getting these double hotkeys, right? So, but part of the solution was, hey, don't switch the value from true to false, delete the attribute when it gets claimed. So they only have, like you said, cars true. Well, they had claimed true. They never had claimed false. They would just delete the attribute when it became. So leverage this capability to create sparse GSIs. We don't want to index data that we're not even accessing, right? So what you're kind of pointing out here is that if I only need to index one type of a product, then make a separate attribute that's being indexed instead of indexing the product attribute, so to speak, to avoid putting all the items onto the GSI.
Yeah, I think that could really help. And the thing that you can do is just create another. We like to duplicate sometimes. We like to denormalize and duplicate. We're not worried about disk space anymore, right? It's 2021. Right. So we'll create another attribute called product cars and just make it null, either null or just doesn't exist at all. We just don't define it because it's schemaless, and that'll keep it out of it. So let's see what that might do. If instead of the GSI replication of 50%, what if we bring it down to 10% because of that sparseness? Now, whoa, the cost of the GSI is like really, really low. Looks like two full table scans would be the cost of maintaining the GSI for the whole month and hitting the GSI as often as we like at that point.
Yeah. So that's a really good point. There are multiple ways to control the cost of the GSI, right? We can index only the state attributes that are interesting for these exception cases, which limits the amount of data that's being written to the GSI, especially if those exception conditions don't change frequently. Certainly decorate the items, decorate the exception items with the exception condition. That keeps all the other items off of the GSI, right? And so you kind of demonstrate multiple techniques here to bring down the cost of this particular GSI to identify whatever items across the table that are interesting to us, right?
Yeah, I think so. So it really helps to understand the shape of your data and some statistics about your data as well.
That's right.
So profile your data, maybe see what are those access patterns, what are the ones that are really needed, instead of a wild card of any product, just see what are the ones we need. So yeah. Now,
this is about. I'm sorry, Rob, but just going to interject here. This is about when I start to hear from developers, but I never had to worry about this stuff with my relational database, right? What do you say to that? When you start going through these cost modeling exercises and stuff like this, what do you say to the developer who says, we don't pay attention to that with my relational database?
So I used to be that developer, for the first 10 years. I was like, I have my table. It's year one of the project. We have, bought a big server with like 128 gig of RAM. everything is cached, everything is magically fast, and you
That's
move
right.
on,
It
and
just
then
happens, right?
the
Yeah.
thing just happens. I don't care about index.
Right. Yeah.
And it's on year 2 or year 3 that they're like, whoa, our data grew way above that size of the memory. Now, like, things are, a lot
Yeah.
slower.
Yeah.
What happened?
Yeah. What happened? Or we need a bigger box, right? So we go
You
get
need
a
a bigger
bigger box,
box.
and everything gets magically fast again, right? And then sooner
Mhm.
or later, I mean, what's happened to me so many times is, guys, maybe we need to look at our queries, right? So
Mhm.
you bring in that guru DBA who's able to just, like, I don't know, slice and dice data like you've never seen, and come up with, replace your gross, disgusting SQL with a couple of nicely designed stored procedures, and some simplified schema and simplified join mechanics. And how do they do that?
Mhm.
Right, they do that by leveraging years of expertise that's
Mhm.
gained through years of knowledge and experience, and it's not common. Right. It's so whenever developers start talking to me about how we didn't worry about that with the relational database, the response is exactly what you gave. It's like, look, you may not be worrying about it right now, and I can
Mhm.
do NoSQL without worrying about it too, right? I'm just going to burn my
Mhm.
fingers a lot faster. That's really what it comes down to, because you don't notice what you're doing when you're burning CPU, right? It's
Mhm.
invisible to you. It only
Mhm.
hurts you when you don't have throughput anymore, right? And those fixed infrastructure services, those servers that have a monstrous amount of CPU, how you use it, well, that's up to you, right? And
Mhm.
in DynamoDB, though, you're paying for what you use, so you know it right away. And in a fixed server environment, you may be burning capacity that you don't even know until all of a sudden you need it, and that's the worst time to find out is when you need it, right?
That's the worst time. Yeah, exactly. Yeah,
Yeah.
that's we're like, it all magically works, then doesn't work. And then the
Yeah,
consultants are gone. They wrote all the SQL store procedures.
that's
I'm like,
right.
well, can we call the vendor? Can we get more memory? Oh no, we're at the max.
Yeah,
So
you're maxed out. You're
yeah.
done, right? And
Oh
so
yeah.
I always tell developers, I say, you think you don't need to worry about this stuff, and that's the worst problem that your future self will be cursing you, right? Is what it comes
Hmm.
down to. How many times have and I've done this, I've written comments in my code, future self, please forgive me, right? I'm doing this now because, and I know that it's going to look so ugly, right? But you always write yourself that note so that in this case, when you design a relational database service on a relational database platform without considering this type of stuff, that's what you do. And you should write your note. Future self, please forgive me for doing these ugly things. I didn't know what I was doing, right? So.
Indeed, exactly. Yeah. So we have good habits now. We're learning some of the basics of indexing and the trade-offs, and it's only going to help us if we ever decide to go back to the SQL world. Rick, we'll know to before we write any SQL, what are the indexes on the table? How do they work, and how can I use them?
That's right.
Yeah.
Because that's the only way to put your data together in a NoSQL database is think about it, right? Yeah, exactly.
Yeah. Oh, good. Before we move on to the next model, so this one has a few more details here. You can see the on-demand pricing. This might be a little bit higher if you're outside of US East, for example. You can change those numbers. And you can I've also put in, we can easily calculate the size of the whole table with indexes or without. And we have other newer features here, like the on-demand backup export to S3 or point-in-time recovery export. So not to get too far into that, but we can protect our data for 35 days at a cost of $38 a month in this case. And we can also dump that for about half that cost into any S3 bucket, and then maybe do some analysis there using our favorite analysis tool, or convert it to
Cool.
Parquet if you like, with Glue, for example. So there's other costs. If you're trying to do this analysis of cars in the table, and maybe these are some other options that you can think about as well.
Mm-hmm.
Yeah. All right, so let's move on a little bit. Let's go back to the second one, capacity decision. So on-demand versus provisioned with auto scaling.
Yes, this is a decision that users have to make every single time you launch a service. As we talked about, it's like, okay, you can go out there with on demand and gather some data, but what do you do with the data, right? How do I analyze what I'm seeing in CloudWatch? Rob's put together a really nice tool here to help users make these types of decisions.
So we're consultants now, and we've been hired by a finance company to set up their DynamoDB table and set up the capacity. And the one thing we noticed, and I've seen this a lot, is these finance companies, they like to do lots of batch jobs at midnight. In the wee hours of the morning, they'll load in all the data for the next day, and the developers will just start their batch job. Maybe it's got even like 100 threads all pumping in data really, really fast. And so right at midnight, the traffic level just skyrockets. It jumps really fast. And then we try to load all the data, and then just as suddenly the job finishes, and we're back down to a low level. So the solution could be, ask the developers to go ahead and just use their knowledge of provision capacity to increase the capacity to, in this case, about 2,500 would do it before the job begins, and then bring it back down. And they write back to us and they say, hey, we're not that good. We're not DBAs. We don't want to change your production table. And plus, how do we even know that's the right level? What if 2 of these such jobs are running? How do we know what the total capacity would need to be if we're setting it directly like that? So we kind of discard that idea. Maybe that's not going to work so well. We need something a little bit more automated. So what about auto-scaling? Can auto-scaling do this for us? Now, the thing about this chart here is a little bit of calculus involved with this. So the rate of change in that first 2 minutes, the first 1 minute, is really steep, right? That's the derivative. It's changing awfully fast. It's almost like a vertical line. And that's the enemy of auto-scaling. I think we want to have something that's a little more gradual, a little more steady, and changing a little bit slower. That will let auto-scaling also react in time. So what I've done here is this other sheet. We have a model like this. So on the top right, you can take off these little show things. There's our original traffic pattern for the bulk load, right?
So you could plug in your CloudWatch, traffic that you're seeing. You could recreate that into this Excel spreadsheet and make it look just like that, right? This is,
Yeah, exactly. You can, if you want to do it even faster, you can do 80,000 a minute, faster and shorter, for example. So we're going to load 60,000 items per minute. We're going to load 3 million items in total. It should take us about 50 minutes to do that. Item size is 2 kilobytes. And let's go ahead and see what might happen if we turn on provision capacity with auto-scaling. And what I've done here is I've tried to take the behavior we know auto-scaling triggers do in CloudWatch, which is to look back 2 minutes of the past and use that as a trigger to scale up, and then 15 minutes of reduced capacity to come back down again. And so what we're seeing here is that this is like 0 to 10 minutes, this first interval. So it does take about 5 to 6 minutes before auto-scaling really gets it in gear and comes and scales up. And at that point, we're at risk. The batch job is going to have probably some throttles and some errors in the first few minutes. We can model that. We can just subtract these 2 lines and go ahead and put that in yellow, and that's the risk. It may be retried. It may be handled by burst capacity, or it may just be an actual problem we have to deal with.
So this is just kind of demonstrating what kind of throttling you might expect to see before auto-scaling kicks and gives you the capacity you need. So you can make some decisions here, right? Do I want to deal with throttling request retries? Do I want to adjust my auto-scaling parameters somewhat to accommodate this? But this is a nice way to visualize what's going to happen when you see this traffic hit the table and how fast the traffic hits the table, right? We can adjust the ramp rate, so to speak, of that, right? In this one, you're showing me an ETL kind of kicks off at 100%. But I think Rob's tool gives us the ability to show the slope, so to speak.
Oh, hold on. You're giving away the spoiler.
I get it. I know. This is the part that I love the most, right?
Okay, before we get to that. And so in this section here, we have the 3 controls for auto-scaling. And when you set up auto-scaling, these are the few decisions you have to make. You can set a minimum and a maximum, and then a target utilization. So before midnight, we can see that we're at about 200 some traffic is bouncing around. And we want to be, have a minimum of 500 there. So that's going to be never less than that. So I've seen developers do this. They're like, well, this is really bitten us. And let's just set a minimum of 2,000 in this case. We're always at 2,000. And guess what? It still didn't solve the problem. Even in that first couple of minutes, you still could have throttling because you can't get up to 2,300 immediately. And plus, it's much more wasteful. For the whole rest of the day, your minimum is going to be at 2,000, even when that batch job is finished. Yeah. And that's a big amount of waste that could go on and on here. So that's maybe not the best solution. What if we change our target utilization to 50%? It'll certainly scale up a lot higher, but it's not going to make anything happen any faster necessarily. I suppose maybe the starting point would be a little bit better. What if the table is totally idle? What if we just have like a minimum amount of traffic to start with? That could be even worse, because now, if our minimum here, starting from almost 0, that's going to take 10 minutes or even more to scale up. So having a little bit of baseline traffic is going to help us get to the levels we need to. All right. So the And then finally in yellow here, we can see the price differential. So on-demand, as we said, is generally more expensive for steady traffic. Auto-scale provision price is what we want to get to if we can solve this problem here. So Rick, you mentioned something about a ramp. What do you think we should do here?
Well, so first off, in this type of environment where I know I've got the batch load coming, right? I would advise the team to go with your option 2 on the capacity provisioning that we discussed earlier, which is, bump that while you need it and then drop it back down. But for those sloped workloads, right, where it's like, okay, if workload ramps over a period of time, again, users wake up in the day, they get busy, things start, you see that kind of curve, right? Then I'd like to be able to model that, right? I'd like to be able to see, well, how fast, how much utilization, right? So let's take a look at what that looks like.
Yeah, I think if we just ramp up. So when I wake up in the morning, Rick, I'm not at 100% right away. It takes me at least 10 minutes to get my coffee and get my braining gear.
Exactly.
So let's think about it. What if our batch job could do the same? What if we tell those batch developers to just put a little bit of a ramp into the first 5 minutes? And look, lo and behold, the risk part of the curve is really dropped right down.
Yeah.
And most of it can be handled by auto scaling when it comes up. That's a 5-minute ramp. And this could be a step function or a ramp. If we do 10 minutes, oh my gosh, look, we're just about there. We're going up slowly for 10 minutes. We can handle the traffic once we're auto scaling brings it up, and the throttle risk is down to almost 0. Maybe 12 minutes would do it. Yeah. So we've seen some really advanced customers start to do this already to start their batch jobs slowly, and then that way they can
ramp those up so they don't have to do the programmatic increases. That's way batch jobs could start spuriously during the day and whatnot. But again, you can take your CloudWatch metrics from existing workload. It doesn't have to be a batch job, right? It could be any workload. All we're really doing is saying, okay, well, how long does it take me to ramp from capacity level X to capacity level Y, and that is apparent in your CloudWatch, displays, right? You could say, okay, I need to get from here to here in 15 minutes or in 1 hour or whatever it is, right? And we can plug all that into this spreadsheet and see exactly what that throttling risk looks like.
That's right. Yep. And the ramp as well. So I did a straight up ramp here, flat ramp, but it looks like with auto scaling, it's sort of exponential. It's going to increase your capacity by a certain percentage as thresholds are hit. So you can see it's got a bit of a curve to it. So I guess the ideal ramp would be not flat, but also try to follow that same curve where you get a little bit faster and faster, exponentially over time.
Or be under the curve, right? You want your ramp to be, yes, there you go.
As
you start to break under the curve, exactly. Then now all of a sudden your throttling risk goes just lower and lower, and yeah exactly.
Yep. And the advantage here now is if we had 2 or 3 batch jobs all starting at midnight, and they were all gentle and gradual, then we could stack these on top of each other, perhaps, assuming auto scaling can handle it. But you also might stagger them. Maybe start the next one at 1 a.m. Right. Or at even 20 minutes after it started, once it's normalized and back to good.
So I got to tell you, Rob, the enhancement that I want to see to this tool is that you ingest the CloudWatch metrics from a particular table, and you fill in this data in the orange line there. That can become essentially the curve that we're showing on the CloudWatch chart, and now show me what my throttling risk is at multiple points, right? As it scales both up and down. So I love to see this tool. This is a fantastic tool, and I want to see it evolve. So
yeah. We'll work on that, Rick. I think we can do the CloudWatch CLI commands. We can go and look at some history.
Absolutely.
And grab those numbers.
Grab that data, and we just need to plug that into the tables beneath here, or add a new table, so to speak, right? Yep.
If you want to hack on this is all on the GitHub, so you can hack on it. But
yeah, folks, please do. Absolutely. And anybody who wants to contribute, make this tool better for everybody, feel free. I'm sure Rob will be happy to get to review your contributions.
Yes, please. Essentially, how I built it is there's a few named parameters here, like the on-demand. Well, let's say the baseline. You can see on the top left here we have named our things in Excel. So that's nice. And then the actual data set. So you can just define the first few rows here in Excel, and then you see how I selected it all. If you drag down on this bottom anchor point here and drag down, it's sort of telling Excel recalculate, iterate according to the first column. So it's incrementing, and then recalculate all the numbers based on some somewhat complex
some observed
expressions. Yeah.
Yes.
So you can see those on there.
And that's part of the thing here is Rob went through this, exercise multiple times to kind of determine what these slopes should look like, to what the throttling risk looks like, right? This is based on your observed evaluations, right? When you were actually running, sample workloads. Did you get feedback from the team at all on this, or is this something that
I did? Yeah, it might be a little bit optimistic. So it's looking at 2 minutes of history to scale up. Now,
right?
there's sort of another delay. There could be another 2 or 3 or 4 minutes to actually perform the capacity increase. So that could actually make it a little bit slower.
Okay. So again, let's tune this. Let's evolve this. This is a fantastic tool for our customers and for our internal SAs, partners and consultants. And it kind of demystifies what happens, right, when I have workloads and I have auto scaling and these are my settings, right? This gives people a little bit more comfort, when they launch, that they're going to be configured within some expected, range of operations, right?
Mm-hmm. How are we doing on questions, Rick?
Looks like Kirk's been online, so he's been answering a lot of the questions, which is awesome.
Oh, thank you, Kirk.
I haven't seen a lot of stuff up there. It looks like we're coming up on the top of the hour. I've had pretty good attendance. Seems like people have been interested. If there's any questions people have, fire away. Rob and I are here, and again, really nice set of tools that are available for you. That I think we posted the GitHub. I can post it again, so people can go up there and take a look. Feel free to make some make some suggestions, contributions. We want these tools to grow.
One final thing, Rick, if you're still showing the screen, so in the README on the GitHub page for this project, you can actually tweak it to be a really, really spiky, like we talked about in the very beginning.
Sure.
So here's a workload that scales up and then comes down pretty quickly. And you can see that because it's one single spike essentially, that there's 15 minutes of extra capacity. And look, lo and behold, the on-demand price in this case could be more than the auto-scaled provision price.
There you go. So that where's that break point again? And these are the types of tools people need, right? Should I run this workload in on-demand? Should I run this workload in auto-scaling? These are the types of tools that people can use to help answer those questions. Are they always going to give you the right answers? No, but they're going to be close, right? And it's only those corner or those close conditions where the cost is approaching equality that it's going to give you the wrong answer, right? I mean, if anything's skewed one way or the other, this type of analysis is going to point it out, right? It's only going to get questionable when things get close. Well, if things are close, then it's not that big a difference, right? So that's okay, right?
That's right. Yeah. I understand. Yeah.
Awesome. Cool. All right. Well, thanks, Robert. Thanks so much for coming on the show. This has been fantastic. I really appreciate your creativity in building these tools, and for folks who are interested in the hands-on lab, where we kind of go a little bit more into the discussion around data modeling and whatnot. We have the database modernization week, which is something that I don't have the registration page for, but if you Google AWS Database Modernization Week, you'll get the next event, and you can register for that, and all kinds of interesting conversations around things, design patterns, data modeling, tooling, and whatnot. Again, no more questions online, and so Rob and I are going to sign off here. Thanks everybody for taking the time, and we'll see you in a couple weeks.
Thanks, Rick. Thanks everyone. Cheers. Bye.
Bye, Rob. Talk to you later.